Welcome back to the course Site 101X on Technology Evaluation. I'm Dan Fry, and I'm going to be discussing suitability, and in particular, the water filter comparative product assessment that was conducted by the Comprehensive Initiative on Technology Evaluation. Into the product family, we studied 11 different models in two major categories: reverse osmosis versus gravity non-electric. The two reverse osmosis systems are based on a technology in which pumps generate high pressure that drives the water through a membrane. The gravity non-electric systems all work on the principle that there is a higher location for the water, and then there is flow driven by gravity into a storage location which is lower, and usually there's a tap for distribution. So the configuration of the gravity non-electric filters was generally pretty uniform. Now the metrics we chose to assess in evaluating these water treatment systems at point of use were 7 in number. 3 of them concerned cleanliness of the water. There was E. coli removal. E. coli is a bacteria that is sometimes found in water and harmful to health in many cases. There's turbidity reduction. Turbidity refers to the clarity of the water, and it's related to particles that sit in suspension. And then there's TDS, or total dissolved solids reduction. The D is for dissolved, which means that it is a different kind of combination between the water and what's been added to the water. And in many cases, that involves salt. The other 4 metrics were related to either economics or usability. The clean water flow rate tells you how long, for example, it would take if you wanted 1 liter of clean water to drink. Percent recovery relates to the idea that in some cases, if you put 1 liter of source water in, you do not get as much as a liter out for drinking. Lifetime, of course, relates to how long the product used. Once you've made that investment, how much time do you get out of it, or how much water do you get out of it? And then there's convenience. And in this case, that ended up relating more to inconvenience, factors that made a particular product difficult to use. Laboratory testing was a very important part of this study. We decided to use the Consumer Reports Lab in Yonkers, New York, because they were well equipped for this. They do assessments of water treatment systems for use in North America, Europe, and other parts of the developing world. So they had the equipment available, and we were happy to avail ourselves of it. But we needed to make some changes to their protocols. In particular, we had to develop different challenge water. We added bacteria to water, which is not something they normally do there in Consumer Reports. Bacteria is a challenge to handle in a lab facility, but we had to make adaptations for that given the study, the functions that we wanted to study. Then we added magnesium sulfate to the water. That is essentially Epsom salts, which we use to consider the total dissolved solids performance criteria. And then we added something called fine test dust, which helped us to evaluate turbidity reduction. So the fine test dust was commercially manufactured and sold to us, and you see here the distribution of particle sizes, which is really quite tight. Now we also did field work, and in our field work we studied 2 more options that I haven't listed so far. There's sari cloth. Here you see a piece of sari cloth wrapped around an outlet spigot, which is draining into a bucket. That is something that we saw observed quite frequently, so we wanted to make an assessment of that. And then there was jolly mesh, this item that looks like a colander here, and since we saw that in wide use, we decided to evaluate that as well, and we did field work on convenience. On to the comparative rating chart. What jumps out most for me is that what we see here at the top are 2 products in 1 technology category. So what we see is that reverse osmosis systems in our study earned the highest rankings, and their ratings were quite a bit higher than all the products in the gravity non-electric category. So comparing the pair that are most nearly the same, there's a difference in over 30 in the overall score. So a big separation between reverse osmosis technology and gravity non-electric technology. That's not to say that there aren't some good options down here. E. coli removal, decent performance, average we'll call it. Turbidity reduction, outstanding. Clean water flow, outstanding. Convenience, outstanding. So some good options. And if cost is essential, those are ones you may want to consider because the cost of the reverse osmosis system's higher than all the available options under gravity non-electric. In fact, the difference is a factor of 2 to 5 in that range. So let's take a second and talk about the method and what we learned about the method having done this water treatment evaluation study. First of all, discovering all the available models in an area is difficult to do, and in this case, the desk study by itself was insufficient. We came across the Dolphin reverse osmosis system, which is locally assembled from commercially available components. We found it early in our field work, and we were able to modify our plans and incorporate it in the study. So the lesson is either find a way to expand your desk study by partnering with local groups or individuals, or else be prepared to discover new things in your field work and adapt quickly. Another issue here is that our scoping decisions for the water filter evaluation were really very different from those made in the solar lantern study, as an example. In the solar lantern study, the technologies were all very similar. There were panels all based on similar technology. There were LEDs and there were batteries, all quite similar in technology. So the performance differences were less in that study. And since in this case we included both reverse osmosis and gravity non-electric, we had a big split in performance. So think about those scoping decisions very hard when you do technology evaluation. Another salient lesson for us was the importance of location. It should not surprise anyone that technology evaluation depends on geographic location, but the differences were more extreme in this case, and for certain kind of products you should expect that. But in water treatment, if a certain area deals with things like arsenic or fluorine, then the recommendations you make about water treatment could be very different. Also, there could be large differences between rural and urban water treatment, and in this case in Ahmedabad, the municipal water supplies were quite good, and that certainly affected how we thought about the study. Here are some image credits. Now, I want to remind you, as always, that doing the exercise that we've laid out for you is important, and you should give that adequate time and effort. Thank you.